Hello, in this problem we are going to look at solving using the idea of a ratio and proportion. So we know that a proportion is two equal fractions. And we know that in order to be equal, they need to have similar concepts or ideas in both the numerator and denominator. When I read this particular problem, this particular med is available in an ampule labeled 60 milligrams per 2 mLs. I see that labeling right over here, 60 milligrams per 2 mLs. The question I'm asked is how many milliliters are needed for a 45 milligram IM injection. This particular problem could be solved many ways. We could use the nursing formula, we could use a proportion, we could use dimensional analysis, but our goal here is to demonstrate this using the proportion idea. So I'm going to start with the first fraction that I read, which says that I have 60 milligrams over 2 milliliters. And in this fraction, I see that the concept that is in the numerator or top of the fraction is milligrams, and the concept on the bottom of the fraction is milliliters. And in order to make equal fractions to this, I need to continue the concept of having milligrams on top, milliliters on bottom. As I read the question, it asks me how many milliliters. So that is where I'm going to put my X because I do not know. And it tells me there's a 45 milligram injection. So I'm going to put that on the top. So these are two equal fractions or a proportion. Now, the shortcut to solving a proportion is to cross multiply. When we cross multiply, we multiply diagonally. So multiplying this way, I have 60x. Multiplying on the other diagonal, 45 times 2 is equal to 90. To complete solving, I will divide on both sides by 60. And so using my calculator, 90 divided by 60 gives me 1.5. And looking where my X is, I see that my label is milliliter. So this problem we were able to solve using the concept of a proportion, which is the concept of two equal fractions. Let's try a second example. So for this problem, as I read through the problem, it says there are 6 milligrams of med in 4 tablets. I'm going to put those together because they are concepts that went together. 6 milligrams of whatever medication is what's in 4 tablets. Using words, I see that my fraction is going to be a milligram over tablet fraction, and I want to be consistent with that setup throughout. As I continue reading, I see the question of how many milligrams. So in my second equal fraction, I am going to put X milligrams, and in the denominator, I'm going to put 0.5 tablets. So I have kept equal concepts at equal locations. So milligrams is in the top the whole way across. Tablets is in the denominator the whole way across. So these two fractions are set up to truly be equal fractions or a proportion. Now, in order to solve, I'm going to use the cross product. So I multiply the 6 times the 0.5 because I multiply diagonally. So when I do that, I have 3. Multiplying on the other diagonal, 4 times x gives me 4x. To finish solving, I will divide both sides by 4. And so x, doing this math on my calculator, would be 0.75 milligrams. Now, one of the ideas of a proportion is that the fractions up here are equal. So I can double check that by looking on my calculator. So on my calculator, if I take 6 divided by 4, I have the decimal. Hold on one moment, let me clear my calculator. 6 divided by 4, I have the decimal of 1.5. And so then if I take my answer here of 0.75 milligrams, 0.75 divided by zero point 0.5, I should get that exact same decimal. So let me try it out. 0.75 divided by zero point 0.5. And yes, I do get 1.5. So I can use this concept to check and to see that I have indeed equal ratios or equal fractions in my proportion when I solve the problem in this method.